Okay, so welcome back, and now here's our first example that we're going to do. And what it's asking us to do is to find the power series representation for g of x equals 1 over the quantity 1 minus x squared on the interval from -1 to 1. And they also want us to test the convergence at the endpoints. Okay, so we want to check, determine whether the resulting series that we're going to find it converges at the endpoints. Okay. Okay. Now, how we're going to do this is we're going to use another function that we know the power series for. Okay. And so, what is that power series? Well, we know that the function f of x equal to 1 over 1 minus x is equal to the power series n equals 0 to infinity of x to the n. Okay? So, and we also know that this is also convergent, right? On the interval -1 to 1. Okay? Or another way of writing this is for all x, the absolute value of x is less than 1, right? So the radius of convergence is 1, right? And this is obviously centered at 0, right? So that's where we get our interval of convergence. So again, a little bit of review. So again, just to make sure you understand what you're looking at. Okay, so now what do we do with this information? Well, what are we going to do? We can find the power series representation for g by differentiating the power series of f term by term. Because notice that, what do we have here? We've got 1 over 1 minus x squared. Here we got 1 over 1 minus x, I'm sorry, misspoke. This is 1 over 1 minus x, and here we got 1 over 1 minus x quantity squared. So, think about 1 over x. If it was 1 over x, we get 1 over x squared, or we get an x squared term in the denominator when we take the derivative. So it makes sense that in order to get g, we can do the same thing with f and do this term by term. Right? So let's do that. So we know what this looks like, right? So this is going to look like 1 plus x squared plus x cubed, dot, 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 right? Okay, so now, so let's integrate this and see what we get. F prime of x, right? Okay, so let's see how we can set this up. I'm going to do, I know the book jumps right in, so let me just show you how you can see this. So we've got this, right? So I hesitate to do this in detail, but notice how you could do a u substitution here, right? So if you take u equal to 1 minus x, and du then equals what? Negative dx. So negative du equals dx. So then you can use the chain rule. Right? So you can do a u substitution here, or you can just use the chain rule without the u substitution. So in any case, if I take f prime of x, then what am I going to get? Again, I've got x, right? And then I've got this here. So if I let u equal 1 minus x, then this becomes 1 over u. And the derivative of 1 over u is what? Negative for what? What do you get? I mean, it's 1 over u, right? So you get negative 1 over u squared, which equals what? Negative 1 over 1 minus x quantity squared. Okay, so that's what you get. And there's a negative sign in there. So you get basically the same thing except for the negative, but again, if we take du, du is going to equal negative dx. Right? And so you can see that the derivative of f of x is going to look very much like g of x. Okay? So let's, again, I just want to see that you can get to the derivative from the function, but again, how do we get to the power series representation for the new function? Okay, so let's start with that. Okay, so here's what we're going to do. We know that f of x equals this, and so, but g of x, right? So g of x equals 1 over 1 minus x quantity squared, which is equal to the derivative with respect to x of 1 over 1 minus x. Okay? Which equals, now here's where, again, we're going to use the fact that since it's convergent over this interval, that we can do the differentiation term by term. So we know that this is represented by this series, but we can bring the derivative inside the sum. So that means this is going to be equal to the sum from n equals 0 to infinity of what? Of the derivative of each term. So it's going to be the derivative with respect to x of what? X to the nth power. And so now here's the thing. Now what we could do is we could use the derivative on the nth term expression. Okay? And so what happens when we do that? Now, again, we can do this term by term, watch, but you'll see where I'm going. So this is just the derivative with respect to x of what? Well, it's just going to be 1 plus x squared plus x cubed, and so on. And then what do? Well, we take the derivative term by term, and what happens? It becomes 0 plus 1 plus 2x plus 3x squared plus, and so on. Which then is really just equal to the summation of n equals 0 to infinity of what? N minus 1 x, oh, hold on. N times x to the n minus 1. Or, now here's the thing. Or, now all I did was use the chain rule here, but if 0's here, I'm going to have a negative sign, so that won't work. But if I look at what's going on here, what this actually is going to be is not this, but I'm just going to add 1 to n. So this is going to be n plus 1 times x, oops, x to the n. That works. Because then when n is 0, I get 1 times x to the 0, which is 1, or 0, so I get 0. And then I get, if n is 1, I get what? Oh, hold on. No. 0, 1. Yeah, I get 1. So this goes away because it's just 0, but I get 1. And then I get, when x is 1, I get 2x to the first power, which is just 2x. And so I get all the terms with that expression. Okay? And let's see here. Okay, let's test the endpoints. Okay? Now, we can test the endpoints by using the divergence test. Okay? So we can find that the series diverges at both endpoints by using the divergence test. Okay? So, if we look at this, if we use the divergence test when x is 1, what do we get? We get 1 to the nth power, and we get n plus 1. So we basically just get n plus 1, which is divergent, right? And then if we use negative 1, right? If we use negative 1, this is also divergent because it becomes an alternating series that has no bound. And it doesn't approach 0, right? Remember the test for divergence. Okay? So both of those series does not approach 0. So therefore it's divergent at both of the endpoints. And that's it. Now, oh, you know what? I'll save that for the next video. Okay? See you then.